The ventilation module will provide an overview of how avionics and electronic equipment is cooled. Then it will shift to a discussion about the main components and the controls and indicators of the system. It will finish with a look at how the system operates normally and then abnormal operations. The ventilation system is completely automatic. It requires flight crew action only if there is a problem. The most important part of the system is avionics ventilation. In an aircraft like the A320, the numerous computers and electronic components generate a significant amount of heat that must be dispersed so that the equipment will function normally. Avionics ventilation cools the electrical and electronic components in both the avionics compartment and on the flight deck. Since this cooling airflow is so important, there are two electric fans that begin operation as soon as the aircraft electrical system is powered up. Other ventilation functions are for the batteries, lavatories, galleys, and the aft cargo compartment. Of those functions, the only one that the flight crew has any control over is the aft cargo compartment temperature. This control is designed into the ventilation system so that the aft cargo compartment can be used to transport live animals. There are a total of 4 electric fans in the ventilation system. 2 fans provide airflow for equipment cooling. They ensure that cooling air is always circulating over the avionics and electronic equipment. These fans run continuously while the aircraft has electric power. There are 2 other fans that extract air and exhaust it overboard. One of these fans takes air from the galley and lavatories to ventilate those areas and remove odors. The other fan draws air from the aft cargo compartment. This creates airflow into the aft cargo compartment from the cabin. If warmer air is needed to control the temperature of the aft cargo compartment, there is a trim valve that will add hot air as necessary. There are 2 openings on the sides of the fuselage near the nose of the aircraft that allow air to enter and exit the fuselage for equipment cooling. The air inlet valve is located on the left side, while the outlet valve is located on the right side of the forward fuselage. One other ventilation function is satisfied by a venturi on the skin of the aircraft that takes air from the space around the batteries and vents it overboard. There are relatively few controls and indicators for the ventilation system. There are blower and extract push buttons that are located on the overhead panel. The normal switch position is not selected. The push button is dark and the system is functioning in auto. Press the button. When a push button switch is selected, override appears in the switch and the system is reconfigured. The fault light will illuminate amber if a fault exists in the corresponding system, such as low fan pressure, failure of the avionics ventilation computer, or smoke in the avionics compartment. The cargo heat control panel has 2 push buttons and a rotary temperature selector. The cargo heat system is set for automatic operation when the aft isolation valve push button switch is not pushed in. The switch will be dark. If auto is the selected position of the switch, the cargo heat system is configured to allow air to flow through the compartment. Press the aft isolation push button to. If the switch is selected to off, the inlet and outlet isolation valves close to stop the airflow and the extract fan stops. The trim air valve closes as well. If the fault light comes on, it indicates that a valve is not in the position commanded by the system. Just to the left is the hot air switch. When the switch is not selected, it is in auto and the trim valve is supplying hot air. Selecting off by pushing the switch in shuts off the hot air system by closing the regulating valve. If the fault light illuminates, a duct overheat has been detected by the system. The rotary temperature selector allows the flight crew to select an appropriate temperature. The range of temperature selections are from approximately 41 degrees Fahrenheit if full cold is selected, to 79 degrees Fahrenheit if full hot is selected. The middle position should be about 59 degrees Fahrenheit. Due to the automation in the ventilation system, normal operation does not require crew input. The type of avionics cooling circulation during normal ground operation is determined by the skin temperature of the aircraft. If the skin temperature is high enough, the ventilation system configures to the open circuit configuration. This opens the air inlet and outlet valves on the forward part of the fuselage to allow outside air to enter and exit. The inlet and outlet valves are either both open or both closed during ground operations. Part of a normal external pre-flight is to verify that the valve positions correspond to each other. If they are closed, the system has gone into the closed circuit configuration because the skin temperature has gone beneath the temperature threshold. In flight, there are also two possible modes of operation for the system: closed and intermediate. Closed in flight is the same as closed on the ground. The intermediate position opens the air outlet valve slightly to increase airflow over the avionics equipment for better cooling if the skin temperature is above a temperature threshold. There are limited options available to the flight crew for abnormal operation of the ventilation system. If the system detects smoke in the avionics ventilation air, fault lights will come on in both the blower and the extract push buttons. The proper course of action is to select both push buttons to the override position. Press either push button. This selection turns off the blower fan and allows the air conditioning system to supply cooling air. This air is then exhausted overboard. In addition, the extract fan remains operational and vents the smoke outside. An abnormal configuration of the ventilation system occurs when the pilot selects either the blower or the extract push button to the override position. This action would be commanded by the ECAM system if a problem is detected with the equipment cooling. Press the When either push button switch is selected to override, ventilation will go to a closed configuration and air conditioning air is added to the ventilation air to augment the cooling airflow. If there is a controller failure, the system will configure itself to provide avionics cooling with air conditioning air, and the extract fan will continue to operate.